Hello and welcome back to Wingot Plays Nomifactory. Today we're working on making some glycerol because glycerol is a key component in making epichlorohydrin, which is going to allow us to make epoxy and finally get to this next tier of the microcircuits, getting those circuits up and running. So to make glycerol we need to actually produce biodiesel. We were making, was this biodiesel over here? No, this was doing something else, I think. This was making fermented biomass, and then it outputs, I forget what that outputs, but for now anyway, I've quickly set up a advanced brewer here, which is taking rubber tree saplings, and it's running at 4 times the speed of that old system there. So it's making biomass at a reasonable clip. The biomass is then being converted directly into ethanol, and then that ethanol plus fish oil will allow us to get glycerol and biodiesel. We just need a tiny pile of sodium hydroxide dust as well in order to get this produced. So we're just going to need another chemical reactor, which we're fast running out of components for. We need more aluminium cables? That can't be right. We've got 2 sitting there, so why did that fail? Whatever. We need more stainless steel rotors yet again. Let's make 4 of those, and we're going to need some electric motors. Good. Now we might run into neodymium issues. Can we make at least 1? No. I'm going to have to fix the neodymium issue that I have been neglecting. So, neodymium dust. We can get that from centrifuging, basically already having neodymium. We can get this impure pile from pulverizing crushed neodymium, which comes from neodymium ore. The thing is, I don't think we can purchase... Oh, we can purchase neodymium. So let's do that. Let's just purchase some neodymium ore. Give me a full stack of that. We'll put it through our processing system over here. Good. Now that should macerate. Perfect. So that'll macerate into crushed neodymium plus some monazite. Crushed neodymium will then go through the pulverizer again to make impure piles, which can then be centrifuged into neodymium dust. Yeah, centrifuged here. Perfect. Making neodymium dust. Good. And then that should solve our neodymium issue for the time being anyway. Because we should be getting... Okay, we're getting neodymium dust, but it doesn't have anywhere upstairs that it can store. So I guess the neodymium that we already had was just being stored in the standard AE system. Let me just quickly put this away. There we go. And we can put neodymium here into our... It's getting very full up here. Into our drawers. And we'll throw the monazite in there as well. Going to just quickly give it a storage upgrade because I always do, and then that should fix the issue there, and we should be able to make some of these motors now. Perfect. Good. And it will process up all of that neodymium and make like 128 or something. Now, that should then allow us to make the chemical reactor we're going to need to make this glycerol. But in the meantime, we're also going to need a fluid extractor to turn the fish into fish oil. So let's make 1 of those. We're going to need a EV tier fluid extractor, which is definitely going to need pumps. But does it need motors? No, it's fine. Good. So that can go there, and in fact, we're going to need this immediately back. So the chemical reactor is going to go here. Perfect. Chemical reactor gets to go right there, and the chemical reactor needs to be fed with the output of this and the output of this. So you are producing ethanol, which can go into there. Then we just need fish to be placed into here. So let me grab a couple of item filters. this gets to configure to only rubber tree saplings. Good. And then we need some more item conduits, I think. Good. To go all the way over to here. And this one is going to be accepting fish. Standard raw fish. Good. Insert on brown, don't extract. Good. And then if we go like that, ooh, let me just check on this. Let's check on this. We need, nope, not that. We need fish oil, which comes from standard raw fish. Yep. So, raw fish. I broke it. Rubber tree sapling. Good. Put that there. Perfect. So, we should now be getting fish here. Making fish oil, which can automatically output into here. We're getting fish oil, we're getting ethanol, and then we just need to input the tiny piles of sodium hydroxide, which I believe the system doesn't know how to make. Why? I thought we had sodium hydroxide though. So sodium hydroxide made from salt water, sodium dust plus water. Let's just do that process for now. So we're going to need a chemical reactor yet again. Perfect. That can go here, and it is going to need water. So we need another one of these we've got the fluid there, so bang, it needs water. Insert on brown, and it is also going to need the sodium. Normal sodium dust, perfect, insert, good. So you need to expose sodium dust to the system, getting put in there, perfect. Now the last thing is it is also going to need a configuration chip set to 1. Okay, you integrated, give me one of those and configure that to 1. Perfect. That can go in there, and then we just need the water, which means we just need to connect this to the fluid system. Good. Now we're getting sodium hydroxide dust and hydrogen. So the sodium hydroxide we probably don't want to put into the system, but what we can do is sodium hydroxide needs to we need to make tiny piles of sodium hydroxide. So what we can do, let's extract the fluid. The hydrogen can get pulled out of here. Perfect. And be reused. The sodium hydroxide, we need to make tiny piles. I can make an unpacker. There we go, advanced unpackager. Let's try to make that. We're going to need conveyor and robot. I don't know if the system knows how to make those at the EV tier. I would not have thought it does. So, we need advanced unpacker. Let's teach the system how to make that and that. Good. Now, we need a conveyor and we need a robot arm. Conveyor, EV, let's make 2 of those, go. Robot arm, EV, we'll make 2 of those. And I did see that we're very much out of refined processor mainframes. And those are going to take a little while to craft. So what I might do is I might just drop a break in here, because it's going to take a little while to craft up those mainframes and the robot arms, and so I will see you all in just a moment. And welcome back. I have now made the advanced unpackager, so let's go put that in place and continue with our plan here. So that can go there. We need this sodium hydroxide dust to be output to the left side there. And then we need a configuration 1 integrated circuit. Good. That gets to go there. This sodium hydroxide, does it have another use? I'm going to be needing it for epoxy, it looks like. So we'll probably also be extracting that. Sodium plus water. Okay, that's free. So 20 pile of sodium hydroxide, perfect. Now that can go into here. So we want to insert on brown tiny piles of sodium hydroxide. There. Good. Insert. And then this can extract on brown. Go. Good. So that should be going into there and making glycerol and biodiesel. Perfect. Now we can put both of those back into our system. Give me 2 of those. What is on this card? This card has nothing, doesn't it? Yeah. Glycerol. Good. And biodiesel. Perfect. So you can put this one away for now. We have made so many fluids in the last couple of episodes. We just need to extract from here. No. No. What am I stuck on? No. From here. Here. Extract. Go. Oh, I see. Fluid extract. Go. Perfect. So glycerol is going into the system, biodiesel is going into the system. And we're out of diesel. And ethanol. Okay. Now, meanwhile, we've still got oil coming in, so this should still be able to process, and we can figure out what we're short on later on. But for the time being, we have glycerol, we have biodiesel. It's actually the glycerol that we're particularly interested in, though. That one there. Which should, I would think, be the quest. Perfect. Good. Because that's what we're going to need for epichlorohydrin. Epichlorohydrin. Colorless liquid with a pungent garlic-like odor needed in the production of epoxy. Yes, that's what we are working on. Epichlorohydrin, which needs chemical reactor with hydraulic acid and glycerol, makes water, and epichlorohydrin. Or hypochlorous. So, let's see. Let's look here. Chlor. We've got hydrochloric. We don't have hypochlorous in the system, so it's probably easiest at the moment to just use this hydrochloric, to make epichlorohydrin. We get 1,000 out of 1,000. Oh, and this also needs allyl chloride, not glycerol. So I think we are going to go this process here. So for that, I'm going to need another chemical reactor, which hopefully we have everything we need to make. Make 10 of those. Go. Meanwhile, I'll make 100 of those. Yeah, okay, good. We've fixed the neodymium issue. Wow. Temporarily, we've got 118 there. We do have a little bit of extra ore there, though, so how about we process that while we're at it? And I might just get some more neodymium ore processing while we're waiting. There we go, perfect. In the meantime though, that should be working very soon. We're just waiting on an electric motor. Again, I think it's because I told it to craft 10 instead of just 1. but that should, well, it needs to make the neodymium anyway, so that's going to be limited by these blast furnaces, which for some reason are making stainless steel. Let's take that out and get the neodymium prioritized. In fact, what I could do is redistribute so that, yes, it'll be slower throughput, but what? Okay. Then I can easily solve this problem, I think, by just turning off 3 of these blast furnaces. There's no power up there. Have I... These are all producing max power. I think I have managed to overload my grid. That's what I think is going on here. Because I've got so many EV machines running. Okay, so what I can maybe do... See, no, you're still not running. I can't change the priority here. Okay, temporarily, let us do this. Let us just disconnect our EV machines from the system, just so that we can make the neodymium that we need. And then I think between episodes I'm going to have to rework my power infrastructure to get a whole lot more shulkers up and running, so that we can expand our numismatic dynamo system. But that... Oh, yuck. Sorry about that. But that should get this refilling, I think. It's still struggling. These are emptying. There's probably other systems that are completely drained of power as well. Yeah. Good. That one still looks like it's running. Yeah, it hasn't broken. The CEF is drawing power as well. Actually, it's going down on power. What's it powered by? Oh, because it's drawing power from here. Yeah, this is all just looking pretty ugly. The AE2 power bank is not maxed out. There's just so much of the base is just out of power at the moment. So yeah, that's never a good thing. All the processing machines here look like they would still be running. The AE2 system never actually went down, so, and that capacitor there will refill pretty bloody quick at that speed. Down here we weren't even using this power, and in fact there isn't even a battery down here. So yeah, I think I'm just going to have to wait while the power replenishes across the base to get the blast furnaces back online. Sorry about that. I think it's probably worth putting a second pause into the episode though, because at this point I'm just waiting on that power to be restored. I will see you in just a moment. And we're back. I have reconnected to the system now. I've shut down most of these blast furnaces. That guy there is now finished running. So any of them, the aluminium was automatic. We don't need that running for the time being. Aluminium ingots upstairs. I've actually disabled these ones over here as well. So they stop trying to make annealed copper and energetic, energetic alloy, which I've got almost a full drawer of, and the annealed copper I've got 1850, so we don't need either of those urgently at the moment. But what I have done is, because I've managed to turn that back on, we now actually are producing epichlorohydrin. I don't know if I'd actually had finished off the epichlorohydrin build just before I paused, but it's fairly simple. All I had to do was put a chemical reactor on the end here, which is being fed hydrochloric acid and the glycerol. Yeah, glycerol plus hydrochloric acid makes epichlorohydrin. Perfect. And now we've got a couple of fluid interfaces that are full of epichlorohydrin. So if we just pop over here, put in our new epichloro drive, then we will have in the system 20 buckets and counting of epichlorohydrin. Perfect. Now, did that work? I don't think it did. Let's grab it again. Perfect. So we have epichlorohydrin. Now we need to make epoxy, and then we'll be able to make the epoxy circuit boards. Two primary approaches to producing epoxy, either bisphenol and naphtha. Both approaches require epichlorohydrin, which itself has a few possible approaches. Let me just put this away. There we go. Naphtha is the simplest approach, where it is mixed with nitrogen dioxide and epichlorohydrin to yield epoxy. This approach is easier but yields less epoxy. You also forego making more diesel and getting distillation byproducts from naphtha. If you have an extremely robust oil drilling and petrochemistry infrastructure in place, this might be an acceptable choice. I don't know that I would call it extremely robust at this point, but it is functional. BPA can be produced using petrochemistry, distillation products, or via distilling charcoal byproducts from your pyrolysis oven. Well, I definitely don't have an automated pyrolysis oven. Alternatively, you can get phenol from coal pyrolysis. Fermented biomass is also useful to distill, as it provides many useful products. Epoxy made from BPA is more complex to set up, but also far more efficient. The final decision is down to you. Check out recipes in JEI. I think I'm probably just going to go with the naphtha recipe for the time being, and epoxy resin sheets. So epoxid sheets is the goal. So we can get rid of glycerol here. Neodymium, we'll come back to that. The epoxy resin, so epoxid sheet is actually the goal. To get epoxid sheets, we need a fluid solidifier. Yeah, a fluid solidifier with epoxy resin. Epoxy resin can be made in a chemical reactor using naphtha, epichlorohydrin, and nitrogen dioxide. Well, we've got naphtha, nitrogen dioxide, and epichlorohydrin in the system, so let's just fire up one more chemical reactor, one last chemical reactor, EV machine hull, make 10 of those. Not even going to struggle at all. And then, as soon as that EV machine hull's ready, we can make that chemical reactor and pop it over here. Yep, like right here. Oops, good, that's been made. Perfect, that can go there, and bang. Now, this guy is going to need to be fed with... Let's grab the end fluid conduit. Perfect. So, it needs nitrogen dioxide and naphtha. Well, we've already got nitrogen dioxide here. So, let's put that one in. Nitrogen dioxide. Perfect. We have... Oops. Nitrogen dioxide, naphtha, and epichlorohydrin. We can put naphtha and epichlorohydrin over here. So naphtha, there. Good. And in here, naphtha. And then we just want epichlorohydrin as well, which is being pumped back into the system and out of the system. Good. So now we just need to connect both of those. Don't connect that at all. And then you are going to be extracting on brown. You can insert on brown. Good. So that'll be getting the nitrogen and then the other two. Naphtha, and it'll get epichlorohydrin in just a moment. and it does not need a configuration card. Perfect. So as soon as we get the epichlorohydrin in there, it will start producing our epoxy resin. Perfect. So we're getting epoxy resin. Let's take a look at this. It can be used to make... Do we want the fluid, or do we just want the sheets, is what I'm wondering. I feel like we want just the sheets, because when we want to later do this, we can always make the epoxy resin by extracting down the sheet into the resin for when we do the chemical bath process. So I think for now we are going to just make the epoxid sheets by using a fluid solidifier, or a fluid solidifier with a plate mold. I think that's going to be the goal for now. So fluid solidifier, EV, go. Good. And then we need mold plate. I don't think we've got any... Oh, we've got blank mold there. Not block, we need plate. Good. Oh, you're telling me I don't have a hammer? I've got an aluminium hammer. Weird. Good. So that can go there with the plate mold, and you can output to the right hand side and make epoxy sheets. Perfect. Then we just need somewhere to put these epoxy sheets, and we don't want to just dump them into the AE system, because then we'll just overload our drives. So what I might do, let me grab a chunk of these, and then we'll grab a drawer, a standard, actually no, we're going to use a oak drawer. We won't grab a new drawer, we'll actually put it over here in... Yeah, whatever, it can go there. Cool, and so now if we connect that drawer, let's see, what do we have here? We don't have item conduits running, they end here. So I think we're going to need some more item conduits running along. Okay, we don't need that piece there. I should grab out the yet arrangement, I need to destroy it, but just being lazy really. Perfect. Now, good. And now we want to go down there to grab this output. Okay, it's over there. So let's pump through the line that we already have. Okay, let's take a look. I need that piece. That piece. Oh, okay, I think it is already in there. Okay, so we want this to extract into the drawers. Where am I? Here. Is that connects, good, and then that can go there. And then we want to extract into black, which will pull it into the drawers. Perfect. And so now we should have epoxid sheets available in our applied energistic systems. Perfect. So we now are at the point where we can make epoxy circuit boards using epoxid sheets, copper foils, and sulfuric acid. 25 seconds, okay, in a chemical reactor. So let's take a look here. Question is, I don't think any of our chemical reactors use sulfuric acid. In fact, they wouldn't, because our system didn't have sulfuric acid previously in it. So how about this is such a mess at this point. What I could do is I could just put a chemical reactor at the back here. Oops. Let me actually check on something before I do that. Let's look at you. Only 10 EU per tick. Okay, so we can use an MV chemical reactor. Bronze rotor. Cool, make a couple of those. And electric motors. MV, make a couple of those. And copper cables. Fine, that's very easy to do. And a MV machine hull. Perfect. Now, when those are finished crafting, we will be able to make our advanced chemical reactor. We need a fluid interface to feed it with sulfuric acid. Where's our MV machine hull? Come on, it shouldn't be they just need to make the aluminium plates first. Okay. That's done. Perfect. Advanced chemical reactor gets to go there. Now it's going to need to be fed with... Interface is going to go on top of it. So we'll put this fluid interface there. This needs to be sulfuric acid. Good. And then we can pump out the sulfuric acid. Extract on brown. You can insert on brown. Good, we're getting the sulfuric acid. Perfect. Now we need a normal interface here, which needs to be connected. So let's just put a piece of ME conduit there. Good. Now this just, oh, actually, before we do that, we need to configure this so that it can import and output from the top. There we go. Good. Now we can put the interface there. And we just need to give it a pattern. Here we go. Epoxy circuit board. That's what we're aiming for, isn't it? Yes. Epoxy sheet, copper foil makes epoxy circuit board. Perfect. Now if we go here, then that can go there, and you can be set to output your product. And we should be able now to make an epoxy circuit board. Good, that will go into there. It'll craft up. It says 25 seconds, 10 EU per tick. Okay, I think it's running at double speed. I think that was probably about 12.5 seconds in total. But there we go, we've got our epoxy circuit board. That is going to allow us to actually move on to the microcircuits. So, very nice. We obviously have power issues that I'm going to need to solve, but we can easily just tell the system, I want to make those. Now, the other thing is, I did notice, so the system also, epoxy substrate, let's grab that circuit board out, perfect. I did also note, so it says we need an HV assembling machine in order to make these microcircuits. I thought that that seemed a bit odd, but I went looking and I saw that the microcircuit runs using 400 EU per tick. The MV that all of our processing here is only 128 EU per tick. So we are going to need to set up at least one HV assembling machine in order to make our microcircuits. But my goal is to replace the whole of the processing system with EV tier, and frankly it looks like we are pretty close to being able to go EV tier. We were able to, with very little problems, create all of this as EV just as we went along. So I think that what I'm going to do is just set up a temporary system in order to make our microcircuits MV tier with an HV tier system, so that we can then bunny hop into EV tier pretty immediately without setting up much in the way of MV. But that's a problem for next episode. Thank you for watching. Stay happy and healthy, and I hope to see you in the next one.